Did you know there could be up to 1 septillion stars in the universe? That's a staggering number. Our Milky Way alone boasts over 100 billion stars, including our Sun. Stars are enormous balls of hot gas, primarily hydrogen with helium and trace elements. Each star has a unique life cycle, lasting millions to trillions of years. Their properties change throughout this journey. Stars begin their life in vast clouds of gas and dust known as molecular clouds. These clouds can range from 1,000 to 10 million solar masses and stretch for hundreds of light years. As these cold clouds collapse, pockets of high density form. These clumps can collide or gather more matter, enhancing their gravitational pull. Eventually, gravity causes these clumps to collapse, heating up due to friction. This process births a protostar, which is the infancy stage of a star. When numerous protostars form together, they create stellar clusters within stellar nurseries. In the early stages, a protostar's energy mainly comes from the heat of its collapse. After millions of years, the pressure and temperature in the core soar, allowing hydrogen nuclei to fuse into helium. This process, called nuclear fusion, releases energy that heats the star, preventing further collapse. Stars that are fusing hydrogen into helium are known as main sequence stars. This is their longest life phase. Over millions to billions of years, their luminosity, size, and temperature evolve. Our Sun is currently in this stable phase. A star's mass dictates how fast it consumes its fuel. Lower mass stars burn longer and cooler, often for trillions of years. In contrast, massive stars burn quickly, living just a few million years. As a star approaches the end of its life, its core exhausts its hydrogen supply. Fusion-driven energy can no longer counterbalance gravitational pull, causing the core to collapse. This collapse increases the temperature and pressure, leading to the outer layers expanding. For low-mass stars, the outer atmosphere expands and converts helium to carbon, becoming subgiant or giant stars. Our Sun will undergo this phase in several billion years. Eventually, outer layers are ejected, forming a planetary nebula, leaving behind a white dwarf, a small, cooling stellar remnant over billions of years. High-mass stars undergo a more dramatic end. Fusion creates heavier elements, advancing until silicon fuses into iron. This process produces energy that delays the inevitable core collapse, but it does not last long. Once the iron core collapses, a powerful shock wave is generated, resulting in a supernova explosion. What remains is either a neutron star or a black hole. The material released during these stellar events enriches molecular clouds, enabling the birth of new stars. Understanding the life cycle of stars reveals the grandeur of the universe. Explore more fascinating topics from NASA to learn about our cosmos.
Thanks for watching Zenvix. Subscribe for smarter health and science.